Hey, this is Mr. Hansen. I wanted to join you for a little bit of instruction on a parallelogram. So the idea is if you're given some ordered pairs, 4 of them, that represent the vertices of a quadrilateral, can you determine if it's a parallelogram or not? So I've got that situation right over here, and I actually have the ordered pairs plotted out on a graph so you can tell. It kind of looks like a parallelogram. Maybe we could think about how you know it's parallelogram. So maybe you're thinking, well, I can see AB has a slope of 1/2 and DC has a slope of 1/2, and then AD has a slope of -1 and BC has a slope of -1. So one way to show that that a shape is a parallelogram is to show that the opposite sides have slopes that are the same. So this is number 2 right here. Also, if you were to draw a parallelogram, just 2 sets of parallel lines like that, what happens is opposite sides are also going to be congruent. So we could measure some distances and see if they're the same as well. And then finally, this is kind of an interesting situation. If you were to draw, this is number 3, diagonals bisect each other. If you were to draw the diagonals first, so I'm going to draw a line, and then I'm going to just stick a midpoint right there on that line. And I'm going to draw another line and make that the midpoint of that other line. Now if we were to graph or plot, make some line segments to each of these endpoints, you'd recognize that it would be a parallelogram. So that's maybe a third way to show that a shape is actually a parallelogram. So with all of that said, let's do all 3 ways on this one, and we'll call it good on that part on this video. In a later video, I'll show you how to determine if a shape is a rectangle, a rhombus, or a square. These are all special parallelograms. But let's go ahead and finish this up. So from A to B, you might notice that we could say rise over run. So 5 minus 4 is my rise. 5, there's y. Y, 5 minus 4, that's 1. And then 4 minus 2, that's 2. 1/2 is my slope. Now, we have a slope triangle that we can also use in terms of the distance. So we plug the 1 is a leg and the 2 is a leg, so we plug it in. 1 squared plus 2 squared, that's going to be square root 5. Okay, let's take a look at BC. 5 minus 3 is 2. And 4 minus 6 is -2. So 2 over -2, that equals -1, slope of -1. And if we plug this in, 2 squared plus -2 squared, again we're just taking the legs of that slope triangle, and we get 4 plus, that's 8, square root 8. Okay, we do it again for CD. This time it's 3 minus 2, that's 1. And 6 minus 4, that's 2, 1/2. And we kind of expected that to be the case if this is a parallelogram, because these slopes are the same. And if we did the distance formula, you can see that it's going to be square root 5 there. Okay, DA. So let's go 2 minus 4, that's -2. And 4 minus 2, that's 2. -2 over 2, also -1, which we kind of expected because opposite sides should be they should have the same slope. And then I'm guessing a square root 8 there. But let's just go ahead and check it. So -2 squared plus 2 squared, and we get square root 8. So far 2 different ways to show that this is definitely a parallelogram. You can take a look at the slopes of the opposite sides. They're the same. And then this one's the same as that one. Or you can take a look at the distances of the opposite sides, and they're also the same. So either of those methods works. Let's do the last one. So we're going to draw a line from AC to BD, or from A to C and B to D. Something like this. So let's do B to D first. We're going to find the midpoint of BD. So let's see, 4 plus 4, that's 8 divided by 2. That's my x, and 5 plus 2, that's 7 divided by 2. So we get, that's 4, and 7 over 2, 3.5. 4 comma 3.5. So that's the midpoint. And if the midpoint is the same for AC, then we'll know that it's a parallelogram that way. So let's see, 2 plus 6, that's 8, divided by 2, and 4 plus 3, comma 4 plus 3, that's 7, divided by 2, which is 3.5. So since the midpoints are the same, they bisect each other, and that is a parallelogram. So three different ways to determine if a shape's a parallelogram. The big question here is, if you didn't have this coordinate plane, and you just had the coordinates for A, B, C, and D, would you be able to do that without even using a picture? I bet you could. Thank you for listening in, and have a good day. This is Mr. Hansen signing out.